Welcome back everyone. Today we are going to discuss about moment of inertia for a shaded area. So I'm going to take an example shown in the figure. You can see in this figure, this is ABCD is nothing but, AOEC is nothing but a square. In the square we are going to cut the part so called triangle and quarter circle as shown in figure. BCD is the triangle and OGF is nothing but our quarter circle. That means in this figure we are going to use as element 1 is square. From the square I am going to subtract element 2 so called triangle, and again I am going to subtract element 3 so called quarter circle, right? So that is our aim. So first of all you must know the following formulas before going to solve the problem. Number 1, area of square, that is A1, is equal to area of the square is nothing but base into depth, so both are equal, b square or d square. And area of triangle is nothing but A is equal to A2, this is A1, so A2 is equal to half into base into H. So here the base is nothing but this is BC is our base, where B is equal to BC, H is equal to CD. This is CD is our triangle height and BC is our triangle base, and B is nothing but AC. Here B is nothing but AC and D is nothing but OA, whatever. This is OA is our D and AC is our B. For quarter circle, the area of the quarter circle is A3 is equal to pi r square divided by 4, where r is equal to is nothing but OF. This is our radius OF. Clear? So that is the most three important formulas before. So this is the formulas are very important to find the areas of the individual section. Similarly, we must know the formula of centroid C, that is G1, G2, G3. G1 is nothing but center of element 1. So we know rectangle element center x1 comma y1 is equal to b by 2 comma d by 2. Similarly, x2 comma y2 for triangle centroid formula is general formula, not x2 y2, general formula h by 3 comma b by 3 comma h by 3 for any triangle of base b h8, and centroid of the quarter circle is 4r by 3 pi comma 4r by 3 pi, where r is the radius of the quarter circle. For this figure, for the following figure, this is radius r, I mean small r or capital R, whatever. The area is the centroid of the quarter circle is 4r by 3 pi comma 4r by 3 pi for any quarter circle. These are the formulas you must remember before going to solve centroid. Coming to moment of inertia, formula of moment of inertia MOI for square or rectangle, whatever the formula, square or rectangle, is BD cube by 12 per square. Similarly, for triangle, this is for IXX, right? For IXX, BD cube by 12. For IYY, DB cube by 12. Similarly, for triangle, IXX is equal to BH cube by 36. IYY is equal to HB cube by 30. Similarly, for quarter of a circle, so IXX is equal to IYY is equal to 0.055 r power 4. So this is the formulas you must remember before going to solve moment of inertia of following sections. So coming to the solution, let me take an x-axis, y-axis. This is my origin, so called 0, 0. Whatever the coordinates, you must measure from 0, 0. This rectangle base and height are adjacent sides of the x and y axis. These adjacent sides are lies on xy axis. Here the base b1 is equal to 150, d1 is equal to 150 because it is a square. And area of the square element 1 nothing but square a1 is equal to b1 into d1 is equal to 150 into 150. Similarly, center for square g1 is x1 comma y1. So this is x1 value, that is half of the base, that is equal to b by 2. This is y1 value, half of the height, that is d1 by 2. So x1 is b1 by 2, y1 is d1 by 2. So center lies is nothing but half of the base and half of the depth. So g1 is equal to 150 by 2 comma 150 by 2, that is equal to 75 comma 75, that is g1, isn't it? That is area of element 1. Coming to area of element 2, that means we need to subtract element 2 from element 1, that is our triangle. So here this figure, this shows that this is the centroid of the element. So this is x2, this is y2. Our aim is to know what is the length of x2, what is the length of y2. Similarly, we need to find the area of this triangle. So area of the element 2 is nothing but half b2 h2. Here b2 is our base, that is 100, h2 is our 5000 mm square, that is our area A2, 500 mm square. We are assuming all dimensions are in mm, that's why you are getting units in mm. And coming to center of element 2, center of element 2, that means center coordinates of element 2, g2 is equal, I want g2 x2 comma y2, x2 comma y2, I need to find x2 comma y2. We know that from here to here, the total length is 150 according to the figure. So from here to here, the length is 150. So from the 150, you must subtract this value. If you subtract this value, you will get x2. From 150 minus, you will get something. 150 minus this value. This value is our triangle base, right? So b by 3, that is b2 by 3. So 150 minus 100 by 3. So now similarly, I want to find y2. So y2 total height is 150 mm. From 150 mm you must subtract this value. This value is h by 3. So to get y2 you must subtract h by 3 from 150 mm. Then only you will get this height. See, this is total height 150. From this I am going to subtract this value. That is h by 3. h2 by 3. So h2 is nothing but 100. So 150 minus 100 by 3. So G2 is our value, x2 comma y2, you will get 116.66 mm, 116.66 mm. Remember one thing, x1 y1 is same, x1 is 150 by 2, that means 75, y1 also 75. Similarly, x2 is 116.66, y2 is equal to 116.66. So you are getting the similar value, so calculation becomes much simpler while finding out ixx and iyy. So you will get majority same values. I mean ixx is equal to iyy, majority. Similarly, we have a quarter circle. This quarter circle is nothing but element 3. We are going to subtract this element from element 2. Right? Here the centroid coordinates 4r by 3 pi, 4r by 3 pi. As I said, this baselines are passes through the xy axis. So that's why you can take directly centroid formula 4r by 3 pi comma 4r by 3 pi. Right? So first of all, area of element 3. So that is A3 is equal to pi r square by 4, where r is equal to 100 mm. So pi 100 square by 4, if you calculate, you will get 7853.98 mm square. Similarly, center location of element 3, that is G3, equal to x3 comma y3, that is equal to 4r by 3 pi comma 4r by 3 pi, right? So that is G3 equal to 4r by 3 pi, where r is equal to 100. So 400 by 3 pi, you will get 42.44 comma 42.44. Here r is equal to 100 mm. Remember, that is the given value from the actual shaded area figure. You can observe the figure, you will get the value. Now, very important one, centroid of shaded area. We need to find the centroid of the shaded area, that is x bar, where x bar is equal to a1 x1 minus a2 x2 minus a3 x3 whole divided by a1 minus a2 minus a3, where a1 is nothing but 22500 into 75 minus a2 is nothing but 5000 into 116.66 minus 7853.98 into 42.44 whole divided by 22500, that is a1, 5000 that is a2, 7853.98 that is but a3. So if you substitute all the value, if you calculate, you will get x bar is equal to 79.916 mm. That is our x bar. Similarly, y bar is equal to, so keep that in a box. Similarly, y bar is equal to a1 y1 minus a2 y2 minus a3 y3 by a1 minus a2 minus a3. So that is 22500 into 75, because y1 is same, x1 is same. Similarly, 5000 into 116.66, because x2 y2 is same. Similarly, 7853.98 into 42.44. Similarly, y3 is same, x3 is same. Similarly, 22500 minus 5000 minus 7853.98. So y bar is equal to 79.916 mm. So that is our answer. Keep that in a box. So this is the centroid coordinates of element 1 and 2. Now this is the most important step, distance between the two axes. What are the two axes? That is very important. So we need to find distance between centroid axis to axis of center of each element. Every element have individual axis, that is x1 y1 x2 y2 x3 y3, and we have centroid axis nothing but x bar y bar. So we are going to measure the distance from those centers. So I can say, so I would like to find h1 bar is equal to y bar minus y1. So where y bar is equal to 79.91 minus 75. Say what I section like this. right? I have I section like this. So let us assume this is centroidal axis, right? This is centroidal axis x bar. Sorry, this is centroidal axis y bar. Similarly, this is element number 1. Element number 1 having the individual center, so called, that is y1. So this element center is y1. The distance between these two centers is nothing but h1. Similarly, h2 bar is equal to y2 minus y bar, largest value minus highest value, 116.67 minus 79.91. This value is 4.916 mm. This value is 36.76 mm. Similarly, h3 bar is equal to y bar minus y3, that is 79.91 minus 42.44, that means 37.47 mm. So you will get the values like this. Similarly, distance between the centroid axis of between x and x bar, so that is d1 bar is equal to x bar minus x1, d2 bar is equal to x2 minus x bar, d3 bar is nothing but x bar minus x3. So if you substitute the values, you will get the same values because x bar, x1, everything will be same. According to the diagram, you will get similar values, 37.47 mm. Dimensions are very important. Don't forget to write the dimensions, that is d1 bar, d2 bar, d3 bar. Now most important step, moment of inertia. Moment of inertia of whole shaded area, whole shaded area about x-axis, that is Ixx is equal to Ixx1, that is moment of inertia of section 1, minus Ixx2 minus Ixx3. So formula for Ixx1 is, already we know that b1 d1 cube by 12. So just substitute b1 d1 cube by 12. And if you apply parallel, so we have two parallel axes, x bar, y bar and y1. So you can apply parallel axis theorem, that is Ig plus a1 h1 bar square. Ig is nothing but b1 d1 cube by 12 minus b2 h2 cube by 36 plus a2 h2 bar square minus 0.055 r power 4 plus a3 h3 bar square. So this is the answer, you must remember. If you know b1 b2 everything, just substitute it. 150 into 150 cube by 12 plus 22500 into 4.916 whole square minus 100 into 100 cube 36 plus a2, that is 5000 into 36.76 square minus 0.055 into 100 power 4 plus 7853.98 into 37.47 square. So if you substitute all the values, you will get Ixx is equal to 1 666 999 8 mm power 4. Similarly, moment of inertia above Iyy, I mean yy axis. So Iyy is equal to Iyy1 minus Iyy2 minus Iyy b1 cube by 12 d1 b1 cube by 12 plus a1 d1 bar square minus Iyy2 is nothing but h2 b2 cube by 36 plus a2 d2 bar square minus 0.055 r power 4 plus a3 d3 bar square. If you know every value, just substitute, you will get same Iyy, that is 1,666,998.8 mm power 4. This is the value of Ixx Iyy. You can solve all the problem in a similar fashion. Only thing is you must know the formulas of it for different section. The procedure, substitution, calculations are same. Thank you.